Question of the Week from the Naked Scientists.
Hello, I'm Hannah Critchlow and welcome to Question of the Week from the Naked Scientists. This week we get our heads in a spin, attempting to address antimatter. Kevin got in touch asking this.
Hi, this is Kevin Fitch from Glenwood, Maryland. As I understand it, physicists have been trying to figure out why the universe is made primarily of matter as opposed to antimatter. What evidence is there that the universe is made primarily of matter? How would we be able to tell if roughly half the galaxies out there were primarily antimatter? Thanks.
So, is there an antimatter planet out there? Could we see one, even if there was? And does it even matter? We take these questions to Tamala Maciel, PhD astrophysicist at Cambridge University. First up, what exactly is antimatter?
Actually, it's very much like normal matter, right? Same mass, same sort of interaction with gravity. It's just that it's got opposite charges, opposite magnetic spins to normal matters.
Okay, and how does antimatter form?
Antimatter comes about anytime you have these really high energy environments, and these can be high energy photons, so gamma rays, or high energy particles that then collide with other particles, produce a bit of light, and sometimes the byproduct of those collisions and interactions in high energy environments are antimatter particles. The problem is we live in a matter-dominated world and universe for one reason or another, and these antimatter particles, as soon as they interact with any bit of matter, they annihilate. And this annihilation occurs in the form of a flash of gamma ray bursts. So here on Earth, we actually create antimatter particles all the time. So in the Large Hadron Collider, this is a very normal byproduct of a lot of the collisions that they're doing at high energies. We also get cosmic rays from space. These are particles streaming towards our atmosphere with very large velocities and energies, and they sometimes collide with the atmosphere, create a bit of antimatter that then annihilates in a gamma ray flash, and we have detectors that are looking for this. The centers of galaxies, we see antimatter annihilation happening around the Big Bang. We expect this to happen all the time.
In which case, would a planet made up of antimatter be stable?
So if we had an antimatter planet or an antimatter star or antimatter galaxy, and it was sitting out in a corner of space completely by itself in a vacuum, right? It would look completely normal to us. We wouldn't see anything exotic about it. It would be radiating the same sort of light that maybe a normal star or a normal galaxy does. It would be gravitationally bound, it'd be very stable. So actually, something completely isolated made of antimatter, we wouldn't be able to tell the difference. And this is because antimatter behaves very, very similarly to normal matter. We've actually experimentally tested this as well. I think a few years ago, the Large Hadron Collider made an anti-hydrogen, so an antiproton plus an anti-electron that was bound together. And they kept it around for 17 minutes. And the only limiting factor of that was simply they needed to keep it away from every bit of normal matter that was around, so the walls of the detector and stuff. Really, by itself, it's completely stable and acts just like a normal hydrogen atom. So antimatter galaxies, on their own, no problem. They would look the same to us. How do we know if they're actually antimatter galaxies out there? The problem is if there's any boundary between an antimatter galaxy and a matter galaxy. And there is stuff. There's gas and dust between galaxies. As soon as antimatter and matter collide, they annihilate, and we would expect to see at that interface a wall of sort of gamma ray emission from all of this annihilation happening. And we've been looking for this, and actually we don't see any areas where there's this large continuous stream of gamma ray photons that would be indicative of antimatter galaxies or stars out there.
Thanks, Tamala. Well, moving to another type of annihilation, from antimatter to ashes. Tracy wrote in with this.
Would cremated ashes, human or animal, have any effect on the growth of a plant? We are thinking of starting a business where we put cremated ashes in a pot with a plant and would like to know how this would affect the growth of the plant.
So, once dead, and if cremated, could a scattering of your ashes help to grow a tree? What do you think? You can post on our Naked Scientists Facebook page. You can tweet at Naked Scientists. You can email Chris at thenakedscientists.com, or you can join in the debate on our forum, which is at nakedscientists.com/forum.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.